Good afternoon, everyone. Thank you for being here today. We are going to talk about Arbitrum Stylus. Okay, we're going to talk like what it is and a bit how interactions between Solidity and Rust contracts work. So let's start it. Well, first of all, I'm Jose Franco. I'm an integration engineer at Off-Chain Labs, and these are my Twitter and Telegram handlers. I don't post a lot of things on Twitter, and Off-Chain Labs they are the initial builders of Arbitrum 1 and Arbitrum Nova chains, and the developers of Stylus and Orbit. If you don't know what any of this means, please go to our booth, and we will be happy to answer all the questions that you have and talk about this. Okay. So today we're going to split the presentation in the workshop in two parts. The first one is just an introduction to Stylus, what it is, and we're going to see a very simple contract, a counter contract. And then we're going to go one level deeper, and we're going to talk about interactions between contracts that are written in Rust and contracts that are written in Solidity. We're going to talk about reentrancy as well and see an example project. So what is Stylus? Stylus is an upgrade to the the current development environment for smart contracts on EVM chains. So basically now if we want to write smart contracts, you usually do that in Solidity or in Viper. And with Stylus, you are able to write smart contracts in Rust, C, C++, and other languages, okay? The way this works is that alongside the EVM, there is a new virtual machine that executes programs written in WASM. So actually any language that can compile down to WASM can run on this virtual machine. And both virtual machines can speak to each other. So that means that contracts for Stylus can call contracts in Solidity and the other way around. These are some numbers of developers in these three languages that we were just mentioning, just to compare among them, and also to see that Stylus actually enables new developers to be able to access the blockchain ecosystem, the smart contract development ecosystem, right? Stylus also increases the speed and reduces cost, basically because generally a program written in WASM is going to be more efficient than the one written in Solidity. And also memory usage is improved. And yeah, that means that we can see new examples of advanced cryptography, generative art, on-chain generative art actually, and any other use cases, okay? So right now we have an SDK for Rust, C, and C++. If you are going to build something on Stylus during this weekend, if you want to do it on Rust, there is a great SDK for doing that. But basically any language that can be compiled to WASM can use a Stylus. And actually we have examples of programs written in C and assembly script as well, without the use of any SDK, just in raw WASM code. And well, this is a bit to show the roadmap of Stylus. Now we have an alpha version with a testnet. We are having audits for the code. Once we make sure everything is safe, we will enable Stylus on Arbitrum testnets and Orbit chains. And finally, we will submit a proposal to activate Stylus in the Arbitrum mainnet chains. So how to start with the Stylus? If you haven't done anything, I always recommend these three resources. Don't worry about the links, because at the end of the presentation, I'm going to show you a QR code that goes to our repo that has all the reference links that I'm going to show here, okay? So there is a quick start. It's a page in the docs. It helps you set up your development environment to start writing smart contracts in Rust and deploy them to the Stylus testnet. Stylus, by example, has more information about small details that when you write smart contracts in Rust, you have to take into account. Like, for example, how you emit a log in a smart contract, right? Stuff like that. And Awesome Stylus is a repository of projects that have been built, Rust and other languages as well, for Stylus. Okay, so you can see many more examples of things that you can do there. All right, so let's see the first example of a contract. This is going to be a very basic contract that just has a counter and allows you to increment it. So with this, we are going to see how the code looks like. So let me go here. Yeah. Can you see the screen well? Can you see the code? Yeah? Okay. So this is a basic example. If you have developed with Rust, well, this might be a bit familiar to you. So here, I just wanted to show you a bit what a contract written in Rust look like. Okay. So this contract is called a counter, and actually, we just declare here the variables that we are going to use. We are going to store in the contract. We just have one variable. It's the count variable. It's a U256. And then we have the functions that we can call on that smart contract down here. The way we divide this is by the use of macros. So we can see here the Solidity storage macro that tells Stylus that we are going to define the struct that is going to tell the contract what variables we are going to store in the contract, right? The entry point tells Stylus where the execution of the program begins. And finally, the external macro tells Stylus what are the functions that you are going to be able to call from outside the contract. Okay? If you want to place some internal function or something like that, you can place it before the external macro, and it is not going to be exposed to the public. So this contract has three simple methods, sorry. A getter to get the current count, a set count if we want to change that, and an increment, okay? And yeah, I'm going to show you how to deploy it. Actually, this repo is also part of the resources, and you have all these scripts to perform these individual actions like deploy, get count, increment, and we are going to use it now to test it. So, sorry, I'm going to use this console, which is, I think is bigger here. All right. So for example, if we want to deploy this specific contract, we're just going to call deploy. And what this does is that it's going to send the transaction to the testnet, in this case, to deploy the contract and also activate it, okay? Normally, you will see two transactions here, but because I've already deployed the same code before, I don't need to activate it. It's how Stylus works. You need two transactions, deployment and activation. If you activate it once, you don't need to activate it again. The same code. If I change anything in the contract, I need to activate it, okay? And just to show you what it does, actually, if I do this, what it calls is just, it uses the cargo stylus command. If you don't know what this is, don't worry, the Quickstar explains what it is. It's just a util that is a tool that we use to deploy contracts, to estimate gas, to check if the WASM code that we have is compatible with Stylus. And yeah, it's just a tool for deploying and checking your contract. So once we have the contract deployed, we're just going to call, we're going to call a couple of functions, and let me show you what these functions look like. So we saw the deploy. We're going to call getCount. And for this, we're going to use cast call. And as you see, we're going to call this as if it was Solidity. We're just going to call the get method that we saw before. And then in the increment script, we are just going to call the increment method with cast send, because we are changing the storage value, and then another get to get the new counter. So let me show you this. So we do contract address because we need to pass the contract address and call get count. Counter is 0 because we just deployed the contract. So we do increment now. Just sending the transaction to the testnet now. And there we go, and the new counter is 1, okay? All right, so this is the first basic contract. Let's go back to the presentation. Again, if you go to the repository of this specific project, It also has all these that we just saw, all this, the scripts, it explains what it does and all that, okay? So yeah, I say this because I'm maybe talking too fast, so you can do that at your own pace later. Now, second part of the workshop, how to interact with other contracts. As we saw, we were interacting with the Rust contract that we just deployed as it was Solidity. And this happens because these stylus calls are what I mentioned there, Solidity ABI equivalent, meaning that you just need to know the signature of the function that you're going to call, and that's it. You don't need any implementation details or anything. And the way you interact with other contracts is actually the same as in Solidity. In Solidity, you will import the interface at the top of the contract or whatever you want, and then inside the method where you want to make the call, you just use that imported interface to make the call, right? So in this case, if you are writing the Rust contract, it's actually the same. You import the interface with this instruction, sol interface, and then you configure and make the call with call. We're going to see an example now. So this is an example of a Rust program that is declaring a Solidity interface. And notice that we are declaring the interface as we do in Solidity. We are actually using the same syntax as Solidity. Balance of is written in camel case, and actually this is a signature that you use in Solidity, right? And when you call that contract, that method, what you do is that you create the variable of the interface that you just imported. You create the call. This call new, what it gives you is a configuration to make the call, and then you just call the balance of function. You send the configuration that you just crafted and the parameters of the call that that balance of is expecting. In this case, just an account. Notice also that even though we used camel case to declare the interface, we are now using snake case here, the Rust syntax, okay? More things. When we are creating the configuration for the call, we can also we can change the values, some of the parameters of the call, like the gas used or the value that you want to send, and yeah, all these parameters. All right, so let's talk a bit reentrancy, because in the Stylus works a bit different. Reentrancy, as you know, is like one contract is calling another contract, and that contract is calling the same first contract again. So we say that that first contract is being re-entered, all right? So in Stylus contracts, by default, this is not allowed. This call will revert, meaning that if you have a Rust program that calls another Rust program, and that one calls the first, the call is going to revert, okay? But this can be enabled by using the reentrant feature flag. And well, if enabled, this will happen. Stylus will flash the storage cache, and it will persist the values that might be used by inner calls. And actually, you do those inner calls by using the new in method instead of the new one, right? And something cool about Stylus is that you can actually apply different logics in the same function, depending on whether or not a call is reentrant. So you can have the same method and say, okay, I want this piece of logic for the first time that I'm calling this contract, and then this second one for when it is re-entering the contract, sorry. And you can know if a call is re-entered or not by using this MSG reentrant variable, sorry. Well, yeah, we have some more references here. Okay, so let's now take a look at an example project. This project is going to have 3 contracts. It have an ERC721 contract written in Rust, an ART contract written in Rust, and an ERC20 contract written in Solidity. And we are going to see the following interactions. So the ERC71 is going to initialize both the ART and the ERC20 contract. In this specific case, when calling the token URI contract of the token URI method of the NFT contract, the image is going to be generated by the ART contract. So it's going to make a call to the ART contract. And when minting an NFT, we are going to check the balance that the minter has in the ERC20 contract. Okay, so the minter will need to have a minimum balance of that token to be able to mint. Okay, the code is here, so let's take a look at it. Yeah, here. All right, if, I mean, this code is much more complex than the previous one, so don't worry, you can take a look later at it. But I'm just going to explain the important things that we just saw, okay? So in this repo, we have these three folders, this art folder, ERC20 folder, and NFT folder, which contains the three contracts we just mentioned, right? The NFT contract is an Stylus project. It has the main file, which is the lib.rs file. And here, and it also has the ERC721 implementation that we are using as a base for our NFT. This code is based on another code that my colleague Rachel wrote in one workshop last year. So if you've seen, it might look familiar to you if you've seen that workshop. So this contract, what it does is that it has the following storage variables, following struct. So we are storing here the art contract address and the ERC token contract address, because we will need those to make the external calls, and then all the variables that are exposed are stored in the ERC721 implementation, right? And well, the functions that this NFT has is, well, the basic functions of an NFT: mint, safe mint, burn, token URIs, all that, okay? Now, the art contract is also a Stylus project. Okay, and this one is a bit simpler. It only stores the token contract address, because we will need it for one thing that we're going to see later. And then it has the generate art function, which is going to generate the art based on a token ID and the owner. Okay, it's going to generate the same image, but the colors are going to change based on the token ID and the owner of that NFT, and the initialize and the getter of the storage variable. Now, notice here that we have a function called generate art and a function called generate art with owner. But we are using the same macro on top of those functions, which is generate art. Here we are telling Stylus that for both method, we want like, if we are calling this contract, if we are calling the method generate art of this contract, either of these two functions are going to be called. And Stylus is going to determine which one based on the arguments that we pass. If we pass only a token ID, this method is going to be called. And if we pass a token ID and an owner, this method is going to be called, okay? We don't necessarily need to do it this way, but I'm going to show you why I did it this way later. Okay, and finally, the ERC20 Solidity contract is just a basic ERC20 contract based on the Open Zeppelin implementation, and just has the mint function. And I've added here a mint NFT function to be able to mint the NFT from here. Okay, so I want to show you how we've implemented the interactions between the different contracts here. So if we go up to the interfaces that we are importing, we can see another example. So we are importing here both interfaces, one for the art contract and one for the ERC20, and we are importing the methods that we are going to use. Generate art. Notice that we are using the method that takes two arguments, token ID and owner. So we are going to call the second method of the two we saw, and the initialize, because we need to pass the different addresses to all the contracts. And for the ERC20, we just need to know the balance of the user who is going to mint. So we just need to import that one, and the set NFT is for the special function that we added. So let's take a look at how token URI method is implemented. Okay, so when we call the token URI method in this contract, as we mentioned before, we are going to generate that image in the art contract, which is another stylus contract, right? Because we are following the implementation, the standard ERC721, so we only pass a token ID. And what we do is that we get the owner of that token ID here, and then we make the call to the art contract here. We just declare the, well, we get the address, we declare the variable, we craft the configuration, we take just the default configuration, and we call generate art. We call generate art, and we pass the token ID and the owner, okay? And what we do in the, when we receive the call in the art contract, we mentioned that we are calling this one because we are passing both parameters. We call the gen art internal method, and we create the PNG, and we just return the base64 string of that PNG, right? Now, we could also have called these generate art contracts and only pass the token ID and give the responsibility of finding the owner of that token ID in this contract, in the art contract. But the problem is that if we do that, the first thing that we have to do here is to find the owner, is to make a call to the NFT contract to find the owner of that token ID, right? And if we do that, we will be re-entering the first contract. So the alternatives that we have here is we either enable re-entrancy on Stylus for this contract, or we do what we did here, which is we create a different method to avoid the re-entrancy call, the re-entrant call, okay? And that's the Stylus contract calling the other Stylus contract. Now, if we go to the mint function, we have two minting functions. One mint that just mints the token to the user who's making the call, and mint2 who mints the token and sends it to another address. And they both do basically the same. They call this internal method. User has enough ERC20 token balance. And if it has enough balance, it will mint the token. So when we go to this internal method, we see that we are going to make a call to the Solidity contract. And we do it like this. Basically, it's the same as calling the Rust contract. We just take create the ERC20 token contract variable based on the interface we imported. We craft a new configuration, and we just call balance off on that contract. Okay, so we are making two external calls, one to a Rust a Stylus contract and one to a Solidity contract, and we are doing it the same way here. We are treating everything the same way, right? And finally, I wanted to show you also, the call that we are making in the ERC20 contract, because this one is interesting. So we are allowing a user to mint an NFT from the ERC20 contract. And the only thing that we do is that we import the interface of the NFT contract. We just need the mint2 function, and we make the call down here to the mint2 function, right? So remember that when we call the mint2 function here, we will check the balance that the user has in the ERC20 contract. So what's happening here is that the user is making a call to the Solidity contract, who's calling the Rust contract, who's then calling the Solidity contract again. We have a re-entrant call there. But this one is not going to revert because it started with Solidity and it's re-entering Solidity, okay? I hope you guys are not dizzy with all these calls that we are making here and there. But I hope you get the point. So basically, in the end, we are calling different contracts. We are making calls between different contracts, but we are treating the interfaces the same way. It doesn't matter if it is a Stylus contract or a Solidity contract. And I think we have time to run some scripts here. So we have in this folder, in this script folder, we have a set of scripts that just perform individual actions. So we are going to first deploy the contract. We are going to use cargo stylus deploy for the stylus contracts, and we are going to use forge create for the Solidity contracts. So we are going to run that. and see some examples there. Okay. So let's first deploy the contracts. Okay, and here we have the same case as before because I already deployed this code in the testnet. I don't need to activate it. It's already activated. And we can see that here. Stylus program with the same WASM code is already activated on chain. This deploy script is also going to make a call to the initialize method to just share the different contract addresses with the different contracts, so they know where all the contracts are and they can interact with each other. Okay. And again, while we wait for this, I know I'm talking too fast, but in the end, you are going to be able to get the link to all these resources, and you can follow along later. So we have these 3 contracts here. So let's first try to mint an NFT like that without having any ERC20 tokens. I think it's this way. Okay, so if I go scripts mint NFT, this should revert because I don't have any ERC20 tokens. So let's mint some tokens. Oh, I can't use that one. Let's mint some tokens here. Wait, because I don't remember now how was the variable called. Okay, ERC20 contracts. I can take this one. So let's mint some tokens. All right, so now let's try to mint an NFT. Okay, and just to show you how the image looks like, let's generate the image. I think it was called get token image. Yeah, get token image. Well, you see the image here. You can see exactly how it is. No, I mean, this script also generates an image in the image folder, okay? So we can see here that it has this small smiley in this color. So we are going to transfer that to another account. We have transfer NFT. Okay, and we are going to get the token image again. Well, these scripts actually work like, for example, I've hard-coded everything. When I transfer a token, I'm always transferring the token ID serial to the same address. And yeah, the same for generating the image. So if we see the new image, now the face is red. That means that it's taking a different owner. And yeah, and I think that's all. There are a bunch of scripts more that you can play with. All of this is explained in the repo, and I'm actually going to show you now the QR code because we are running out of time. And yeah, there you have it. Again, this QR code will point to the repo of the project we just saw with the 3 contracts. In that README. In the README of that project, you are going to see all the resources that we just mentioned. If you have any doubt about this presentation or Stylus in general, you can find us at our booth. You can also ask on Telegram or Discord. And I think that's it. I hope I wasn't like too quick and that you got everything that I wanted to say. Okay? Thank you very much.